All right, so this lesson is lesson 24, classification trees. What we're going to do in this lesson is a little different than what we talked about. We're not going to do bagging today. What we want, Colonel Linquist and I sat down and we talked about, like, what do we want you guys to be able to do or really understand? So we feel like if you understand how to split the predictor space for one variable, or I'm sorry, one leaf, then we feel like you'll really understand what's going on here. So I'm going to do this sort of one step at a time, and I'm going to show you at least one thing that's not in the book that sort of confused me when I programmed it. So I programmed it according to the book, and it didn't do this little piece here. So let's go ahead and get started. So we're splitting a predictor variable. Now we're going to come up with a way to figure out which predictor variable it is, and we're going to see that hopefully it comes up to the same thing that scikit-learn does. So remember Gini index, right, for region M, and all this was we wanted to make this variance of this Bernoulli random variable as small as possible. I'm sorry, the Bernoulli random variables, right? So we're adding the variances of each class and coming up with a value for region 1 and then a Gini value for region 2. However, you can't just add those together. So that became evident when I tried to compare my results to what scikit-learn was doing. So what the book doesn't tell you is that what you need to do for the Gini for this tree right here. So this is the tree, and we're calculating, okay, well, how does split equals 4? How does S equals 4, this split here, where you have region 1, all the points that are left of x1 is equal to 4, and then all the points that are right of x1 equal to 4, right? So that's all these points. How do we figure out what the Gini value is for those, right? Like, this is the thing that we do for one of the regions, and then we would do this for the second region. But how do we do it for the entire sort of split here, right? So there's a G1 value here, and if most people, already asked that question, they'd probably say just add them together. But the problem with that is these probabilities that are up here don't give you an idea of how many points that you're actually classifying correctly. So that's the idea there. So what you're going to do then is use this thing called, since R1 is a set of points and R2 is a set of points and R is all of the points, then this R1 divided by R, so this is the cardinality or the number of elements that's in that R1 set, and then the number of points that are in the total R1 set. And basically what we're doing is multiplying by some kind of proportion, right? So this is the proportion that's in G1 of all of the points, and then the portion that's in, region 1, and this is the proportion that's in region 2. So this, again, not what the book tells you, but it's sort of this weighted average of G1 and G2, so that this thing called a Gini, we can actually compare it to other splits. So that's the idea. So I want to be able to use this thing right here, and then I want to be able to find the best split. So right now, I just said, x1 is less than a 4. I don't know if that's a good split or not. I haven't calculated this thing. I'm gonna let the computer do it here in a second. But the data, the blobs that we're gonna work with now look like this, right? So maybe this is a good split. I don't know. X -4, maybe -5. So let's just do -5. So the first one that we'll work with is this -5. So is x1, if this x1 is less than, so x1 is less than -5. And it looks, and you can kind of see all the numbers there, and you can see there's like 1, 2, 3, 4, 5, 6, 7. Maybe there's 8 of them that are class 3, and the rest of them are class 2. And then everybody in this side is going to have a certain number of class 2, 3, 1, 0, and 1. So let's do this one first and find out how we can go about doing it. But the overall objective is to then divvy up this space of predictor variables, letting this be x1, right? So I'm going to look at a bunch of different x1s, and I'm going to calculate this Gini for a tree for a whole bunch of them. And then once I have that Gini for the tree and on a whole bunch of these, then I'm just going to select the one that's the smallest, and that's going to be the split that we're going to use. And then we'll do the same thing for x2, break it up into a whole bunch of different places, and then see what the split is for that one, and then find the smallest one there and compare it to this one, and then whichever one's the smallest between those two. So in other words, if this were the best one, oops, Yeah, it's not a very good one. If this ended up being the best one for x2 and it's lower than the best of the x for the x1, then we would use that guy. So that's the idea. That's what we're going to do today when we get to programming. So I'm gonna do that step by step. Hopefully, you guys are following along and understand what's going on. So again, this Genie tree. Okay, so before I get there, before we keep going, we need to understand how would I calculate, like what helper function do I need in order to be able to calculate this? So you, as you would hopefully imagine, given some s, I need to be able to find these p hats. So we definitely need something that has p hats. And then I need, I'm going to call it card. I'm going to have this other data structure called card that we need to have. So what is p hat? Well, in this case, when we're talking about 4 different variables, again, I'm only slicing this up into 2. So it's a binary slice. I got the left-hand side and the right-hand side. So I'm going to look for P11, P12, right? So this would be the probability of being of the P. Yeah, I guess we could put the hats on here. Looks like an R. P12 hat, P13 hat, P14 hat. And then I got P2. So this is region 2, class 1, region 2, class 2, region 2, class 3. And I'm using the linear algebra, not the Python. So obviously, if I'm talking about class 1, 0 or 1, then I'm talking about actually in class 0 up here. Class 2 would be class 1, 3 would be 2, and then 4 would be 3. Okay. So I apologize for this being Python-y, but that's just what we're working with. And the fact that I wanted to use linear algebra, like row 1, column 1, row 1, column 2, row 1, column 3, and so on and so forth. And then I would do the same thing with the cardinality. I need to find this. I need to find N11, N12, N13, N14, N21, and so on and so forth. So we need to find these guys given this set of data. All right, let's jump over to our this is what should be in CoCalc right now. So if you go to CoCalc, you can follow along. And I hit Shift Enter here, and we get the same data because I have it in a certain random state. I'm going to turn that data, this X and Y right now, they're just NumPy arrays. I'm going to turn them into a data frame so you can kind of see what that is. You can see that X1 is all the X1 values, and it's the one that's the X1s that are populated here. The X2 values are the Y coordinates, if you will, and then the Y represents what class they're in, right? So this first one is in class 2, so apparently he is colored yellow. So if you looked at -7, negative 11, -7, -11, you know, it's one of these yellow points up in here, and so on and so forth, right? So you can kind of see how that's working. All right, my first thing that I want to calculate, so this is what I call a helper function, and that helper function is just going to roll out this matrix and this matrix. So that's what I want to get out of that of this code right here. My inputs are the predictor variable for split, my response variable, my k, you know, the classes that I'm considering, and then whatever the split is, and then a p hat and card. So it's a 2 by k columns, or 2 rows by k columns, or a 2 by k matrix, where P11 is the proportion of class 1 in region 1, P12 is the proportion of class 2 in region 1, and so on and so forth. So that's what this represents. All right, so if I'm doing this, the first thing I want to do is I want to separate it. Let's go x. So I want x to be less than s, and that's going to be a Boolean mask that we're going to use. So let's go p hat, p underscore hat, and I'm going to pass in df. We'll do x1. We'll pass in dfy as my y. And then let me move something out of the way on this in my way of programming here. I have my little XP pin that's in the way, so give me a second. All right. So that'll be my y, my response variable. I need k, which is just 0, 1, 2, 3. I know what the k values are. And then my split, I think we're using -5 for the very first one. I think that's what we said. -5. Yeah, so I'm using this one. I'm trying to find, I'm evaluating right now the quality of that split there. So let's go back. All right, so I'll test it, and then Just print it. Print. And you can see that it's just a Boolean mask. And so what is this Boolean mask doing? Is that it's just telling me all of the points from 0 to 300 or 0 to 299 that are less than the value of the split, so less than negative point or negative 5. So now what I want to do is, well, what do I really need? What I really need out of it is the y values. Shift enter, and you can see here that it, most of them are 2s, and there's a couple of 3s in there. Does that make sense? I think so. If I'm -5, most of them are going to be 2s and just a couple 3s. So this makes sense for what we got. And now instead of setting it equal or printing it, I'm just going to set it equal to YL, right? Meaning Y left is equal to that, and then maybe Y right is equal to the same thing, but my Boolean mask is going to be greater than or equal to S. So I think that'll work for us. And then the next thing I got to show you is I had to look this up in the Google machine, but I had to figure out that this np.unique would give us what we're looking for. And if I pass in YL as the NumPy array, and I tell it return counts equals true, then let's just print what we get. Print both of these. So I'm just going to copy paste it in there, Control C, Control V, and Shift Enter. And you can see that so for YL, I have class 2 and class 3 only. I got 42 2s and 8 3s. That's what that passes out. And then we can copy paste, Control V, change that to an R, fourth. Hopefully we get the bottom layer, right? So then we have 75 zeros, and I think that makes sense. If you go back and look at the picture, all of the zeros are going to be left in that one. All of the ones will be left in that one. Let me erase that. I don't like that line there because it looks a little bit confusing. So let me take that one off. Okay, because we're at x1, right? So that's the value that we're splitting at right now. Now, is that the best one? I don't know, but I want to be able to calculate how good it is. I want to be able to calculate this Gini here in a second. In order to calculate this Gini, we said, well, we need this p hat and this this card matrix. So let's finish that up. So I can take away the print statements now because I'll leave them there for a second. And then the next thing we're going to do is we'll say for j, and so for each element in the class, or for each possible class, I'm going to, for nj in range, length of k. Remember what k is. K is the classes to consider, so 0, 1, 2, 3. Then we're going to set, just set I equals 0 for now, and then try. There's going to be a try except here. Now, the question is, and like if we were in class right now, I would ask you why we need a try except, but here, let me just demonstrate it. So IDX is equal to list. So I'm going to turn YL classes dot index KJ. Okay. Matter of fact, let's take it out of here. Let's take the try except out and let's find out what happens. The first time you go through here, think about what's going to happen here. So J's going, I want to go through each one of the classes, and then I want to calculate the p hat and the total number that's in there. And we own the total number because it's right there. So what would happen the first time through? So k is equal to 0, right? And then you're going to come in here and you're going to pass in k0. Well, what is k0? Well, k0 is equal to 0. And then I want to find, so that's the number that I'm trying to find the index for in this first YL classes. Well, we know YL classes is equal to that. Is there a 0 in there? No. Therefore, what's going to happen is it's going to pass out an error. So let's watch the error happen. And it says, guess what? You don't have, there is not a 0 in this list, knucklehead. And so what I want to do instead is I want to do a try. I want to try this. And if it's not successful, then I want to accept, and I don't really want to do nothing. Why don't I want to do nothing? Because I forgot to set up my data frame or my data structures here. So I want p hat to equal np.zeros. Let's see, I want the number of columns to be rows. Number of rows to be 2, and the number of columns to be length of k. I want card to equal NP, same thing. NP.0, same exact thing. Control C, Control V. Okay. And then now we don't get anything because we didn't really do anything. I just ran in and got the IDX, the index. So now what I'm going to do is I'm going to say, well, I want P hat I comma j, right? So see I is equal to 0, so we're talking about the first row of my P hat matrix. And then for every single one of the j's that I actually find an index for, it's going to then calculate what? Well, I wanted to calculate YL counts IDX divided by IL counts dot sum. So all of them on that that are in there, right? So I want to do that. So it's going to be the index for that one, right? So for example, when I get the one where I can do 2, then it'll be, so that number for this 2 would be 42 because counts is the second matrix. So IDX is 0. So what is YL counts of 0? It's 42. And then 42 will be there, and I will divide by the total, right? So I'll divide it by 42 plus 8. Oh, let's print it. Print P hat. All I've done so far is the first. So I've done the 0th row, and it's went in, and we know in this thing we don't have any zeros. We have 42 class 2s, which that's why you got 0.84, 42 divided by 50. And then you got 8, which is 8 divided by 50 class 3s. And that's where you're getting that from. So now what I'm going to do is just do the same thing, Control C, E, and then instead of it being I is equal to 0, or I'm sorry, yeah, 0 would be 1, and then these all need to change to the right-hand side. That's good. That's good. Happens. And then 0.3, so 75 divided by however big this is, like it's 0.3. That looks like it's good. 67 is that, and 33. Yeah, so it looks like it's doing what it's supposed to do. Now I got to go back and tell it card card I comma j just equal to that should be it. And then this one would be card I comma j is equal to, is that the YR counts? Print card. All right, so it should be the same thing here. I got 0 class, so if it's sort of taken this thing and turned it into every single class. So every single class, these should match up with these exactly. All right, I think that's all we need. And so instead of printing now, I'm just going to simply return these two. So return P hat, comma, card. I think we're done there. Delete these print statements. Delete the print statements up here, so we don't have to see those anymore. All right, so then we do that and we get what actually comes out. All right, so I want to now use this. So I'm going to have P hat, comma, card. I'm going to assign it to that, and I'm going to use that down here into the Genie function, right? So that's what next thing I want to calculate. This next helper function allows us to, so I'm going to take away the pass, and we're going to have Genie equals 0. For I in range, we'll go to length of P hat. I could do either one of those two. I know it's just 2. And then I'm going to go through and I'm going to say, well, I want the probability to equal to P hat, the row, so all the row, no, yeah, row I, right? So row I and then all the columns. So that should be it. And then the proportion is equal to card I, all the columns in card dot sum divided by card dot sum. All right, so let's talk about what this one's doing. What did I just do here? I grabbed all of them in the row I, which is what we're talking about here. And then I sum them all and divided by the total. So let's go back over here. So what we're saying is I grabbed this entire, let me use a different color here. So I grabbed this entire row, N1, N2, N2. So this would be the cardinality of R1, and this one here would be the cardinality of R2. And then the entire thing, everything, is the cardinality of R. So now what I want to do is find, well, how do we do the cardinality of R? We just basically do card.sum, right? Card.sum would give me all of these numbers. The cardinality of R1 would give me the first row and add them all up. Give me the second row, add them all up for that one, and you can kind of see what's going on there, right? So that's give me the row, and then that is all of them. All right, so I got everything I think working for us. I know I need to add some things up. I'm going to start off with g is equal to 0, and then I'm going to say g, let's see, 4p(n) probability. I'm going to have g plus equals p times 1 minus p. And then once we get out of there, we will then say Gini plus equals the proportion times G. I could have done this anywhere. I could have done this inside here because the distributor property lets me do it inside, or I could even do it as long as, let's see, as long as this doesn't change, right? So this will change when I go to the next I. So as long as I is good, then I can pull that in that piece in. So I could have done it in here, or I could do it out there. All right, so once we're done adding all those suckers up, I'm just going to return Gini, and then let's do one. So Gini p hat, comma card, and we get some number. So that's good. Let me just make sure that I'm getting the same number if I put it inside here. Same number. Okay, yeah. I just wanted to make sure that that made sense to everyone, and it made sense to me. Control V. Okay, good. All right. So now I have the two helper functions that I need. So think about what we're going to do. I now have a function. If I give you a split, I can tell you what the Gini is. I can go here. I can tell you what the overall Gini is for both sides. So now we're going to do the second part where I said I was going to split all this stuff up, and then I'm going to put in this split, and I'm going to find out what it is, what this Gini is. And then I'm going to put this split in. I'm going to find out what is Gini. So this might be Gini 1, and then Gini 2. ... So they're Gini, I don't know, 5,000. Maybe I have broken this up into 5,000 different places. And then I'm going to evaluate all of them just by simply finding the minimum and then returning out what the minimum S value was, right? So that's the idea, right? So once I found all these suckers, I'm going to keep track of where I split these at and what S values was going in that created that Gini. And then I'm gonna find the smallest one, and I'm gonna return the S value, the split value that does that for us. Okay. So let's go back here, and instead of pass, we're simply gonna put it. We'll call it Gini underscore index. Oops, underscore is equal to a blank list. So that's what we're gonna put everything in. So n is equal to def, no length, data frame, and then the next one is, this next one's weird a little bit. It's not too weird. So class is equal to df. Oh, I forgot to explain this stuff that's coming in here. Let me do that real quick. So unique. So what's happening is I'm passing in the column that I want to evaluate. I'm passing in with the responses, right? So the response is, so in other words, it's just the 0, 1, 2, 3, or 4, whatever numbers are coming up there. And I'm finding the all unique ones, right? So this will give me 4 numbers, not necessarily in the same order that I want them. So then I'm going to say classes dot sort. So that should work. And that'll put it basically in the order that we wanted. And I'm going to let x equal to df column. Y equal to df response. And then x min, x max, x range equals x dot min max x dot max and then so x, let's just break it up and let's just see what happens. S is equal to np dot arrange, and we will go from x min, I don't know, plus 0.1 comma x max plus 0.1 or minus 0.1 then by 0.005. I don't know, just make stuff up here. S, and then for SINS, we want to p hat comma card is just that helper function that we already did, and then pass in what x is, what y is, what classes are, and SI. Hopefully we have all that information. And then Genie underscore index is equal, or dot append. That's dot append. And then we're going to append in Genie, right, the actual function, and then pass in p hat comma card. And then IDX is equal to Genie index dot index, and then I want the minimum. So I'm passing in the minimum value that's in this thing that we created, that we're capturing every time that we increase x by a little bit. I'm just capturing what the new split's given us, and then I'm going in and finding the index to that, the smallest one, and then I'm going to return the following. I'm going to return, see, S is all of those x values. So I want only the x value that is associated with the smallest Genie, and then I'm going to pass out also the Genie index IDX. Here, let's do that and let's see what happens. I don't know. There's a bunch of different answers to it because it is a real number. There's an infinite number of answers, and let's find out what happens here. So 4.65, and we can make this smaller, probably get something a little bit different, but just to remember that this is an infinite number of numbers can be here because there's an infinite number of numbers in between. What really matters is how it's broken up. So let's see how this thing's broken up. Control C, Control V, hopefully it's the same, and I think it is. And then, you get the Genie of that guy. Okay. The question now is, I want to visualize what's going on, and I want to say, all right, I'm going to have 2 leaf nodes, and I want to see where scikit-learn actually does the split. So if you remember last lesson, we had this visualize classifier, and you can see that that it looks like it's in the right spot, right? So, oh, I forgot to say this. So which one of these two would I use? I would use the 5.2y because it's smaller than 5.3. So that's the only reason, right? So nothing other than that. So that means I'm using the predictor x2, and the split is going to be 4.65, and that's why I did this down here. So you can see if I take x2 and I divide it at 4.64, this number that my algorithm came out with, then these are the pH, the p hat, and then this is the actual cardinality of each one of my sets, right? So in other words, I have one that falls in class 0 that's in region 1. 71 that's in this class 1 that's in region 2, and so on and so forth. So less than 4 points. So let's kind of see what that looks like. So this one actually is up here. So it should be classes, so 4.65. Let me just kind of draw that in real quick, just so you guys can see. Maybe 4.65 is right here. So I'm just going to have 0s and 1s in it. Let's make sure that the one above, the YR, has only 0s and 1s in it. And if it doesn't, we got problems. 0s and 1s, right? So that's the YR. That's the one on the bottom. It only has 0s and 1s in it. And then the other one has a little bit of everything. Okay. So let's see where this one split it at, right? And the way you do that, just take these two off and hit Shift Enter. And you can see it does it at 4.652. Remember, there's an infinite number of these numbers as long as 171, 75, 75, 171, 171, 75, 75 is to the left. And then this one is 74, 400, 74, 400. So therefore, it split it in exactly the same place that that scikit-learn did. Okay. That's really all I got this lesson. I just wanted to jump out there and show you that we can actually program these splits, and it's not that big a deal, right? So as long as you have these two helper functions here that we created, it's not that big a deal to do it. Okay, hope you got something out of this one. We'll see you next time.